Hello, everyone. I'm so glad you're here. We are talking tonight about the counting progression. And specifically, there's two different things that when I say counting progression, what do I mean by that? I mean the counting levels that students go through. So there's three different levels. I also mean the counting progressions, which is how a student acquires counting from number word name to number word order to subitizing, perceptual, conceptual, etc. Tonight, we're going to actually talk about the counting levels because those start in kindergarten, really even pre-K, and then they repeat themselves when we get to grade 3 and beyond. So I'm going to talk about how those two start and end, and we're going to start from kindergarten and work our way up past third grade. And so let me know if you're watching. I'd love to hear from you. So let's get started with kinder and our very first counting levels. I'm going to share my screen here and let's get going. So here's what we have. Count all, count by, and derived strategies. Those are the three levels we're going to take kids through starting in kindergarten and then repeating as we get going. So count all. This includes a lot of things like cardinality and number word order. I recognize there's a counting progression that is involved in just this standard. So if you teach kindergarten, I recognize that what I'm about to show you is not second nature. There's a lot of skills just to get kids here. But when we say that kids count all, it means we have something like 3 plus 2. We've taught the quantity of 3. We've taught the quantity of 2. We've taught number word order. We've taught number symbols. We've taught symbols in terms of the plus sign, the minus sign. Okay, all that has happened. And now we're saying the first counting level is count all. So when I say 3 plus 2, a kindergartner might say 1, 2, 3, and then they'll count out 2, 1, 2, and then they're going to count all of it by starting over. 1, 2, 3, 4. So they don't tend to have conservation of number. They can't hold on to this as a 3 and then just count forward yet. They have to count all of the first one and all of the second one. These are students that as we are asking them, how many fingers do I have? They count them, you put them behind their back. They're like, how many do I have now? And they're not really sure. They have to recount them again. They're not able to hold on to the number because they don't trust it yet. They haven't had enough exposure with visualization and subitizing to create those mental images of quantity that they really trust that's how much is there, and they know without having to count everything. But this is the first counting level. Students are going to use materials, manipulatives, etc., to make sure they understand how to count all. I'm good with a K student counting all year long. We're going to work on the next level with them. But they do not have to have that mastered in kindergarten. We want them counting everything, even when they go to make a teen number and they make something like 15. They're going to start to put 10 in a group, and then they're going to have extras. So they know it's a group of 10 and let's say 3 extras. But when they go to count it, they may still count everything. They still may go 1, 2, 3, 4, 5, and all the way up to 13 because they can't yet hold on to that 10 to necessarily count forward. They might even know that 10 and 3 make 13. They know it's a group of 10. They know it's 3 extra. But when it comes to maybe a written equation or an expression or just counting in general, I say, well, how many are there? That's cardinality. They still have to count everything. They don't say, well, 10 and 3 is 13. Oh, there's 13. A kid who has cardinality knows when I say how many, they know there's just 13, that the last word I said counts for the whole group. Ks aren't necessarily always there. We're working on it because cardinality is their standard, but they're still going to count everything. Okay, the next one we have is counting on. So this starts with the 5 group in kindergarten where we trade in 5 counters and we give them a 5 strip for lack of better words, where there's 5 tiles glued together because we want them to see that 5 plus fact that is a part of the learning progression where students will see like the number 8 and they see a 5 group and then 3 more. They start to conceptually subitize with those numbers higher than 5. Okay, so we still give them a 5 group, but that 5 group really has a different purpose. Its intention is not necessarily to count on. So when I see something like 3 plus 2, a student who's counting on might count out 1, 2, 3. They might count out 1, 2. And then when I say, well, how many are there? They'll say 3, 4, 5. They're able to hold on to this as 3 and now count forward in that sequence. Now, we do want Ks to be able to count forward from any number. So there is a component of this we are working on, but we're not necessarily asking them to hold on to that whole number and then be able to count that second add-in. For some of them, that's still very difficult. So we are starting to work on it. A lot of kids can get it, But really, this is a first grade counting level. We want first graders to really get good at counting on with a known add-in and then counting on with an unknown add-in, and then they will count on to find subtraction or count back. Counting back is really inefficient. We say generally we can count back less than 5, but if it's more than that, we really don't want kids counting back as a strategy because it is so cumbersome and so inefficient. Then we get counting on even in second grade where students might see something like 8 plus 6. Now they have 8, they have 6, they counted out both sets, but in order for them to count on, they would take that larger number and they would count forward. But as you know, this becomes problematic. So we're good with counting on for numbers 5 or less. Counting on is a great strategy for that. Or as we get into the upper grades, counting on in groups. That's great. But when we get to second grade, we start saying counting on can no longer be an effective or an efficient strategy when we get numbers that go into the teen additions. So in this case, we would want students now to not count on. We want them to see that we're really forced to go to derived because I'm running out of fingers, right? I don't have enough fingers to keep counting on, like to hold on the 8 and then count on more. So in that case, what we're going to do is we're going to move to derived. When I move to derived, I'm going to do 8 plus 6, and I'm going to think to myself, well, I could put these two over here. And if I did that, I would fill up this group and I'd make a group of 10. Then I'd have 4 left over. 10 and 4 is 14. So it's rewriting this equation into another simpler equation for me to do a mental strategy. But students can't do mental strategies if they've never physically and visually done the strategy. So we're working a lot on students physically moving these two apples over here and then seeing how many are left. If you're in second grade, you're going to do this with the penny strips, right? So as you go through unit 1, students have a penny strip. Let's say it's 8 plus 6. They take the penny strip, they cover up with a sticky note 2 pennies. So now there's only 8 showing. Then they have 6 left over. And we say, well, how many of these 6 pennies do you have to add to that penny strip to fill it up to get to a 10? And they see, oh, there's 2 more. They fill it up. They notice that they have 4 left over. 10 and 4 is 14. They're going to do the same thing with subtraction. They're going to do derived strategies. So when I get to something like 13 minus 9, we don't want the only definition of subtraction to be putting down fingers. Okay, I don't even have 13 fingers to put up. So it's no longer efficient. So we want students to be really careful in kindergarten and first that their only definition is not just taking things away, right? We're also seeing subtraction as inverse addition or counting on an unknown partner. That's really the goal of first grade. I can count on to find the unknown. So instead of 13 minus 9, our younger students are going to make a math mountain, and they might do something like this where they see, well, look, it's 13 is the total, 9 is my partner, I have an unknown partner. Now I can count on, and I'll say 9 and 1 makes a 10, and now I know I need 3 more to get to 13, and all together I added up 4. So the math mountain helps us to see that this is, yes, it's subtraction. Yes, it means something goes away. Yes, I can put down fingers, but the numbers are too big for that to be the only strategy. Now I'm going to actually see it as an unknown addend, and I'm going to count up. All right. Now we go, that's K1, 2. So we count all, we count on, and then we're forced into that derived strategy. Once we get into that derived strategy, we start to see kids commit those to automaticity and to mastery. Now, when we get into third grade now repeats that entire counting progression. So developmentally, this happens all over again. And what's going to happen now is we do count all, but it's with groups. So third grade might do something like 3 groups of 7, okay, or 4 groups of 6, or 3 groups of 3. And what they have to experience, remember, you can't make it a mental strategy if you've never actually physically or visually done it. So in this case, we do 3 circles with 3 in each. I don't put the number 3 in these, okay, because that means a student has to hold on to that. Count all means they see everything, they count everything. So when it's 4 times 6, I'm not doing a shortcut by doing the area model where I just label it 4 times 6. I have to hold on to the fact that this means 4 rows and 6 columns, right? Or let's pretend that's 6. And I see that many squares. So for a third grader who's learning multiplication and division, they have to see everything and they would count everything. 1, 2, 3, 4, 5, 6. We're proving that 4 groups of 6 really is 24. So just like a first kindergartner who's doing 3 plus 2 and they go 1 and 1, 2, and then they recount them all to prove to themselves that really is that number, really is 5. And then they count it again. They're repeating that in grade 3. But we quickly move them from counting all, as you can visually see what's happening here, to moving them to counting on, because of course it's not efficient to count all of them. That's just one of the learning development stages that we want to have kids get through and move quickly into counting on. When we count on, now they say like counting all of these takes forever. So could I count groups? And I see that there's a group of 4 and another group of 4 and another group of 4. So now we're going to count on 4. Now we count forward by groups of, which is a part of that conceptual subitizing. So now students start to see things in groups and they start to count by groups. It's a part of the counting progression. So for those of you who are teaching 3rd grade, 4th grade, 5th grade, knowing our multiples and knowing to count on or count by a multiple is a part of their counting progression. It's a step we can't skip. So a student might just know that 6 times 4 is 24. And I'm like, that's awesome, but that's down the road. You skipped some learning progressions here. I need you to go back and show me that you know how to count by groups. You and I both know they're going to need it for equivalent fractions, common denominators, right? List of multiples. All of those really require students to have what we call their count bys, and that is a counting progression. It also means that students need to be able to count by a number starting at any number. Just like kindergartners and 1st graders have to start counting from 26 forward without having to count all that 26, right? They just know the number word order. It's called reciting. Okay, they're a reciter. We need a reciter for 3rd grade. We need someone that knows that that's just the order I say them in. 6, 9, 12, 15, which is why a lot of you do songs and whatnot. It's just to have them understand the word order. So they have they're a reciter, if you will. However, they still have to be able to count from any of those count bys forward. And if they only can do that when they can sing a song, then they're not really ready for this level, or they're not passing this level. Meaning I want to be able to do something like 6 times 9. Well, I don't know 6 groups of 9, but I know 5 groups of 9, right? And I can say 45, and then I can count on one more group. But if I don't know 5 groups of 9 and I have to redo the whole song, right? 9, 18, 27. If I have to do that, then I'm not actually competent in this learning phase yet. So I have to be able to count on groups starting at the beginning group, 3s. But I also should be able to say count by 3 starting at 15. And I just know the next count in my head. Okay, so we show that visually, we show it with manipulatives, and then students start to know that word order. This moves us then into derived. So a derived strategy now means a student who is using derived knows how to do all their count bys. They've passed that. But now they're able to use that sophisticated strategy that I just showed you. They're saying, well, I don't really like my 4s, but I like 3s. So they take this and they say, I'm going to break it up. And I know that 4 is a 3 and a 1. So I'm going to do 3 times 6, and that equals 18. Then I can do 1 times 6, and that equals 6. And now because I know my count bys, I can do 18 and add one more group of 6. Now, some students are going to have to actually add that, but that means they need to continue to work also in that second stage. It is important that we don't think it's a gatekeeper. It doesn't mean they can't do derived just because they haven't done all their counting yet. They haven't done their count by. It just means I don't want to long-term skip their count bys, because this is when it starts to hurt us. So we continue to work on our count bys, and we can start to teach some of those derived strategies. It's just like in 2nd grade, if we're doing something like 9 plus 6, and I want them to make a 10, and you're like, well, these kids don't know their sums of 10. So they can't make 10 because they don't know their sums of 10. Yes, they can. They're just going to count on 9, 10, 11, 12, 13, 14, 15, and then go back and utilize a strategy. 9 and 1 make a 10, 9, 10. They counted forward for that. Plus we have the 5 extra. So we don't have to pass every single stage in order to start working on the next stage, which is probably what your grade level standard is if you're, for example, in 2nd grade. Okay. And in 3rd grade, we start to work this in Unit 1, but then we heavily work on it in Unit 2. Even if they haven't mastered all those count bys, they can start to think flexibly about these counts before they have all those count bys. Okay, that's the end of the counting progression. We can start to see it repeat itself in 5th grade, 4th grade, when we do fraction work. And when I'm able to count by parts, like count by fourths, 1/4, 2/4, 3/4, 4/4, 1 whole, 1 1/4. And then on a number line, being able to count forward by any one of those numbers, like count forward by fourths, count forward by halves. Okay, all of that starts to continue to impact us as we get in the upper grades. I can see in a 5th grader, kindergarten student who didn't get cardinality and who skipped counting levels. Like I can tell who they are because those are the kids in 5th grade that when I say, where's 2/4, they point to the 2nd, 4th in like a bar model or in a number line. They don't see that it was everything we already counted is what made the 2/4. They really struggle with number lines. Okay. Now that's not because they didn't have number lines in K1, 2. They shouldn't have number lines then. It's just that they don't understand it as a length model and they don't have the counting progression. So we should be counting in every grade all the time by whatever it is that your standard might be or by something they might be missing. Perfect. So Gail says she starts doing count bys in her transitions. And she says, when I'm transitioning, start at 4. I say count by 4. Let's start with 12. That's perfect, Gail. Because what we tend to do is we only count by 4 starting at 4, which we should, because we don't tell like our pre-Ks and our Ks, I want you to start counting at 13 when you're like, they can't even count to 13. Okay, so we have to be able to at least do the number word order the first time, 4, 8, 12, 16, before we start saying, okay, let's start at 16. Now what would you say? And watching to see how many kids have to start from the beginning to know that after 16 comes 20, right? It's the kids that are in kindergarten and they have their purple tiles. And I say, I want you to pull down to 6. And they're not sure which one of those are the 6 until they count them. And they go 1, 2, 3, 4, 5, 6. It's that one. They have to recount it to verify that's what it is. We see the same thing happening with our 3rd and 4th graders. So great idea, Gail. Transition time is when I can do a lot of counting. Even if it's time, when I get to elapsed time, I'll say, I want you to count by 10-minute intervals starting at 3:50 p.m. Part of the reason elapsed time is so difficult is our kids don't know how to count by time or know when things transition. So in like 1st grade, it's really hard to transition over the decade, knowing that it's going to go 29 and they have to go to 30. Hard for kindergartners. It's also hard for 1st graders to go 99 and go over that century and start repeating the pattern into the hundreds. Similar to things like time and money. Anytime I cross over into the next hour, I cross over into the next whole, if I'm counting by fractions or decimals, it's a really difficult transition for students, and we just need a lot of practice counting. All right, friends, let me know what else you're thinking, other things you do. I'd love to hear from anyone else, a strategy you might have, or if you have any other questions about counting, let me know that as well. I'd love to know. All right, my friends, so glad to see you. Let me know in the comments what stood out to you, what was helpful for you tonight, and we'll see you again next week. Bye for now.